Hello and welcome back. Today we're going to learn how to use two colors to mark and connect conjugate pairs on a particular candidate in such a way that will allow us to eliminate other instances of that candidate that are proven to be false. Now, if you haven't watched video number 19 on conjugate pairs, please go back and watch that tutorial right now before continuing here, okay? Great. All right, without further ado, let's go over to the puzzle board and see how this technique works. If you have watched videos number 3 and number 4 at the beginning of this course, then you will find today's lesson very easy to understand. I highly recommend watching those two lessons as well as tutorial number 19 on conjugate pairs before continuing here. Let's first review the formal definition of a strong link. If A is false, then B is true. This powerful conditional statement is at the very heart of the principles we will be employing in this lesson and the next. There is what I call an effective strong link between the two endpoints of an open-ended alternate inference chain. I say effective because the formal definition of a strong link applies to those two endpoints even if they do not see each other. This type of false-true relationship is the result of the string of alternating inferences in the chain. We know that if one endpoint of the chain is false, then the other endpoint must be true, and vice versa. If A is false, then B is true. And there is what I call a conventional strong link between the two candidates in a bi-value cell and also between the last two remaining instances of a particular candidate within a house. This kind of link is a direct link, i.e. the two candidates can see each other. This means one of them must be false and the other must be true. They cannot both be false and they cannot both be true. One must be false and one must be true. This is the only way it can be. It's a verity. And further, when we have a conventional strong link between two same-digit candidates within a house, this is also known as a conjugate pair. This simply means that one of the candidates must be true and the other must be false. There is indeed a strong link between the two candidates in any bi-value cell, but this type of strong link is not called a conjugate pair. The term conjugate pair applies only to the strong link between the last two remaining instances of a particular candidate within a house, i.e. a row, column, or block. When we apply the coloring techniques that we will be learning today and in the next lesson, we will be focusing entirely on strong links, both conventional and effective. There will be no weak links. I repeat, no weak links. We will use conventional strong links to build a network of conjugate pairs, and then we will use effective strong links to make deductions, okay? Simple coloring type 1 and type 2 are both single-digit patterns, meaning we will always be focusing on one particular candidate at a time. We will be using two colors to denote each conjugate pair. The two colors will always represent polar opposites, like north-south, A-B, on-off, yes-no, true-false, or however you want to think of it. Personally, I just use true and false, but you can call them anything you want. And I use blue and yellow only because these are two colors that I can easily see as I am partially colorblind. But feel free to use any two colors you want that you may prefer. It's completely arbitrary. You just need any two colors. Obviously, this is not a real puzzle, so please try to use your imagination. I know it looks like there are several naked singles in this diagram, but please ignore all that and just try to focus on the conjugate pairs and the point I am trying to make. This is only a demonstration. We will look at real puzzles in just a minute. What we're going to do is color each conjugate pair blue and yellow and try to create a network by connecting as many of them as we can. Remember, the two candidates in each and every conjugate pair must be of opposite colors. There must be one candidate of each color in each conjugate pair. You must follow this rule strictly. So let's start in row 3, and since there are only two candidate 3s in that row, that is a conjugate pair. There is a conventional strong link between those two candidates, a direct link. One must be true and one must be false. We can start with either color, it makes no difference, but let's start with blue on this candidate 3, and we're going to make a conjugate pair over to this 3. Then we have another conjugate pair up to this 3 in block 3. They're the only 2 3s in that block. Then we go down column 9, and there's a conjugate pair. And now here's a conjugate pair in block 9. And there's also a conjugate pair in row 9. Now don't make the mistake of going blue, yellow, and tripping yourself up. Like, let's get rid of these. Like if you started here and went blue, yellow, and then you go blue, and you can't go yellow. This candidate 3 in row 9, column 9 is yellow. So that means any conjugate pair coming off of that 3 has to be blue because the 2 candidates have to be opposite colors. So this one has to be blue. All right? So don't go blue, yellow. In this case, you need to go blue, because they're both connected to that yellow 3. All right, let's keep going. In row 7, we've got a conjugate pair there. In column 5, we've got a conjugate pair there. A conjugate pair in row 5. And finally, another conjugate pair in row 1, column 1. And you just keep connecting conjugate pairs until you come to a dead end like we did right here. And here's what the links look like. Those are all conjugate pairs. Now remember, these are all strong links. So just like with so many other patterns we have seen lately, either all the yellow ones will be true and all the blue ones will be false, or vice versa. All the blue ones will be true and all the yellow ones will be false. But either way, we know that any same digit candidate that can see both a blue one and a yellow one must be false. If you remember from video number 29 on remote pairs, the cells alternate between the 2 candidates in the bi-value cells. Like if the bi-value cells all contained a 7 and a 6, like you see here, the connected cells would end up alternating 7, 6, 7, 6, 7, and 6, or they would end up 6, 7, 6, 7, 6, 7. But because we are dealing with only one candidate here, the cells will end up alternating true, false, or false, true, etc. But it's the same principle. Capiche? Now notice what's happening here. As a result of this network we have just hooked up, we have a blue 3 and a yellow 3 in block 1, and we have a blue 3 and a yellow 3 in row 1. But those are not conjugate pairs. There are other 3s in those houses. But because of this network, there is an effective strong link between any blue 3 and any yellow 3. So this means we can eliminate these other 2 3s in block 1, and we can eliminate these other 2 3s in row 1. Those 4 3s would all be false because of the network of conjugate pairs. The difference between this network of links and a regular AIC is that an AIC is linear, meaning it follows just one path from the start point to the end point with no offshoots, detours, or branches like this. But the networks we will be creating using these coloring techniques can branch off at any time, in any place, and in any direction into a row, column, or block, as long as each branch constitutes a strong link, i.e. a conjugate pair. Like this 3 down here in block 9 has 3 conjugate pairs coming off of it. There's one in column 9, and there's one in block 9, and there's one in row 9. And that's perfectly legal. And the other difference is that with an AIC, there are weak links involved. So you can only say if this, then that. But you do not know for certain that the actual values are perfectly and definitely true and false, one way or the other, like you do here, where every link is a strong link. Now, if you have more than one network on the same candidate, you cannot color the candidates in that secondary network, yellow and blue, or whatever 2 colors you are using. It would be a separate entity and would have nothing to do with your first network, like this. The 4 7s you see over here in the beige cells, they are connected, and the yellow and the blue cells, they are connected, but they have nothing to do with each other. You cannot color those 4 7s that are connected by the black lines, blue and yellow. But later on, when we get to multicolors and we are using 4 colors, you can color the secondary network using the other 2 colors, but not your first 2 colors. So with simple coloring, like we are doing here, you must consider only one network at a time in which all the conjugate pairs are connected. Okay? All right, let's take a look at some real examples and some real puzzles. Let's turn on the filter for candidate 4. Now when you're cycling through the candidate filters and you see something like this, where there are an unusually high number of conjugate pairs, you should immediately look for X chains and/or simple coloring moves. If you need to put some weak links in the chain to make it work, then of course you will only have an AIC, at which point you can only make deductions about the two endpoints. But if you can construct the chain or network using only strong links, then you will have a lot more chances for candidate eliminations. So you should always strive for that first if possible. There are 8 conjugate pairs on candidate 4 here in this puzzle, and they can all be linked. So we're going to use blue and yellow, and you can start on any one of them, and you can start with either color, but let's start up here with blue, and that's a conjugate pair to that 4, and there's another conjugate pair over to that 4, and then that's a dead end. Okay, so now let's go down the column. There's another conjugate pair in column 1, so that has to be yellow. And then there's another conjugate pair in column 2, so this one has to be blue because it can see this yellow one up here. Now there's a conjugate pair in block 4, so that has to be yellow. Another conjugate pair in row 5, that has to be blue. And then there's a conjugate pair in column 7, so that has to be yellow. And then there's a conjugate pair in row 9, so this has to be blue. And I think that's all of them. So now we look for any candidate 4s that can see both a yellow one and a blue one, and it looks like there are 2. This candidate 4 can see this blue one up here in row 1, and it can see the yellow one in row 7, so it has to be false. And this 4 right here can see this yellow one and this blue one all in block 9, so that has to be false. As you can see, this was not a conjugate pair to begin with, but because of our network, it allows you to eliminate that candidate 4. Okay, let's go to the next one. Okay, here let's take a look at candidate 1 and we'll light them up. And as I mentioned earlier, as long as you make a conjugate pair, you can start on any one of those candidate 1s, and you can start with either color. So let's start with yellow this time, and we'll start right here and we'll go up column 2, and that's a conjugate pair. Now off of this blue one, there are 2 conjugate pairs. There's one in row 2 and one in block 1. So they both have to be yellow because they can see this blue one. And then in row 1, we have another conjugate pair to that one, and down column 4, there's a conjugate pair to that one. Then let's go back to this first one, and there's a conjugate pair in row 5, so that has to be blue. And lastly, there is a conjugate pair in block 2 that I didn't see before, and so that has to be yellow. Now you have to look really carefully for these because sometimes they're easy to overlook. So there's our network, and now we look for candidate 1s that can see both a blue one and a yellow one, and we've got 2 of them. These 2 red ones, they can see the blue and the yellow one in column 5, and they can also see the blue and the yellow one in block 5. So even though those are not conjugate pairs between those blue and yellow ones, they become effective strong links because of our network, so you can eliminate both of those candidate 1s. All right, let's go to the next one. All right, this time we're going to take a look at candidate 3, so let's light them up. And boy, there are a lot of conjugate pairs in this puzzle. I think there are 12 that we can actually hook up. So let's start up in row 2 on this candidate 3, and there are 3 conjugate pairs coming off of that. There's one here in row 2, there's one in block 1, and there's one in column 3. So those are all yellow. Now in this one in column 1, we have a conjugate pair down to that 3, and then there's nothing over there. So up here in block 2, we've got a conjugate pair to that 3, and we've got another conjugate pair to that 3. They both have to be blue because they see the yellow one. Then down column 5, we've got another conjugate pair. That has to be yellow. In block 5, there's a conjugate pair. That has to be yellow. In column 4, there's another one that has to be blue. In row 9, this one has to be blue. And you can see all of these see each other. But you can only have one yellow and one blue one in each conjugate pair. I think that's all of them. Nope, there's one more in row 4. There's another conjugate pair right here to this candidate 3. So that has to be yellow. And so see, this blue and yellow one now are in block 4, and they are not a conjugate pair. They turn blue and yellow because of this one in column 1 and this one in row 4. So that's how this works. So now we look for candidate 3s that can see both a blue one and a yellow one. And in this puzzle, we've got 2. This 3 right here can see the yellow and the blue 3 in block 4, as I just mentioned. And this 3 over here can see both the blue and the yellow 3 that are in row 5. And again, this blue and yellow 3 in row 5, they did not start out being a conjugate pair. They were only blue and yellow by virtue of this blue one down here in column 4 and by virtue of the yellow one up here in column 1. So these 2 3s are false. But let's go back for a minute. As you can see, there is a conjugate pair between these 2 3s in row 6, but they're not connected to the blue and the yellow one. So you can't color them blue and yellow. And as it turns out, these are both false, which leaves this 3 right here as the solution to that cell because it becomes a hidden single. All right, let's do one more. Okay, this time let's turn on the filter for candidate 5. And there they are. And as you can see, there are lots of conjugate pairs. So let's start up in row 1. Let's color this one blue. And there are 3 conjugate pairs coming off of that. There's one here in row 1. There's one in block 2. And there's one in column 4. And they all have to be yellow because they can all see that blue one. So this yellow one up here in row 1 is a dead end. There are no conjugate pairs connected to that. But the one in column 5, there's a conjugate pair down here. That has to be blue. And then over here, there's another conjugate pair to that one and to that one. And there's another conjugate pair off of this yellow one up in column 8. So that also has to be blue. There are 3 conjugate pairs coming off of this yellow 5 in block 9. Here, here, and here. All right, let's keep going. So now in row 2, off of this yellow one, this has to be blue. There's a conjugate pair to that one. There's nothing down there. In column 2, there's a conjugate pair to that 5. And let's see, what else have we got? In row 9, we have a conjugate pair to this 5 right there. And that looks like that's all of them. And as it turns out, there are only 2 5s left in the puzzle that are not included in this, and they can both be eliminated as false, here and here. This 5 can see the blue and the yellow one in block 7 and the blue and the yellow one in column 1. And this one can see the blue and the yellow one in block 3 and also the blue and the yellow one in column 9. So they are both false. Okay? All right, I think that's enough for now. Following tutorial number 32, there will be an adjunct video number 32A containing numerous additional examples of simple coloring, including both type 1 and type 2. So be sure to watch for that. All right, that's going to do it for today, so let's go back outside and finish up. Thanks for watching. So that was pretty easy, right? In the next video, video number 32, we are going to use the same system of coloring as we did here, except this time we will be looking for a contradiction that will allow us to solve all the candidates of one color at once. This is a very powerful solving technique, so I hope you will join me for that lesson. Until then, be well and be happy.